All right, so it says we're conducting a test of homogeneity for the claim that two different populations have the same proportions of the following characteristics. So basically when we do the test for homogeneity, it's we're trying to see if the columns and the rows are independent or dependent of each other, okay? So the first thing you do is you have to put this information into a matrix, okay? Now, depending on if this is the second or third problem you've done, and you already have stuff in the matrices, I always like to start by resetting the calculator. So I'm just going to go to second, plus, I'm going to reset, I'm going to clear all RAM. Should say something like RAM cleared. And then when you go back to your matrix screen, there should be nothing there, okay? So remember, second matrix, so we're going to go over to edit. We're going to edit matrix A. It's a 2x2 matrix, two things to the left and right, two things up and down. So I'll change this to 2x2. And then just put the data values in. 7, 78, 52, and 77. Okay. And then we'll get out of that. So now we're going to run our test, our chi-squared test. So I'm going to go to stat, over to our test menu. I'm going to scroll over to the bottom. You'll see there's chi-squared goodness of fit, and then there's chi-squared test. We're just running the chi-squared test, not goodness of fit. Hit that. It's going to ask where the observed values are coming from. That's matrix A. We're going to put the expected values into matrix B. So if you ever see like a question ask what's the expected values, that's where they're going to be stored. You can go into that matrix and pull the numbers out from there. So then we're going to just go calculate. That's going to give us pretty much everything we need. So our chi-squared test statistic is going to be 26.398. The degrees of freedom from this test, well, that's right there. DF is 1. And then the p-value, p-value is 2.7787 times 10 to the negative 7. So this is basically okay, it's so small that if you ran it to 4 decimal places, it's just going to be 0. So our p is less than alpha. We don't even care what alpha is. It's 0.05, but p is 0, so it's definitely less than that. So we're going to reject the null because the p-value is lower than alpha, which means there is sufficient evidence to show. Hold on one second. So we're trying to show that these two things are not independent. So the bottom one, if there is sufficient evidence to warrant rejection of the claim that the two different populations have the same proportions for the following characteristics, we show that the proportions are different for the two populations. So that's our alternative. So then we're going to just select that as our answer. These ones are the tricky ones because they intentionally word them to be confusing. Warrant rejection of the claim. It's really, really confusingly worded, but do your best.